So we start our journey in chapter 9. We are going to do a lot of pretty cool things with triangles in chapter 9. But before we can get into a lot of that stuff, we have to do some review of some essential algebra skills. So 9.1 is 100% review. We're going to review all about radicals, simplifying, adding, subtracting, multiplying, dividing, everything with radicals, which also kind of pulls quadratic equations into play as well. We're going to be doing all of that stuff with quadratic equations, solving, factoring, quadratic formula, all that good stuff. So this is your one-stop shop of review, but hopefully you remember a lot of it. So here we go. First of all, some basic operations with radicals. So number one here would just be to simplify a single radical. So if I have the square root of 48, now 48 is not a perfect square, right? If it was the square root of 49, that would be very easy. Square root of 49 is 7, right? But I need to remember what to do when I have a radical that's not a perfect square. So if you remember back to last year in algebra, we talked about looking for the perfect square factors, right? What things multiply together that would give 48? If one of those factors is a perfect square, I got to pull it outside of the radical, and I'm looking for the biggest perfect square that's in there, right? So we could say, okay, well, the square root of 48 is the square root of 4 times the square root of 12, right? 4 is a perfect square, so that would be good. However, 12 isn't done yet because 12 has some perfect square factors as well. So I could say, oh, 12, the square root of 12 is really the square root of 4 times the square root of 3. So I need to keep going until I get all of those perfect square factors out. So the fastest way to do it is to think of your factors of 48 and look for the biggest perfect square possible right away. The biggest perfect square factor of 48 is 16. So I could break this into the square root of 16 times the square root of 3 and get to the same place that I was just looking at, but in a much faster way, right? The square root of 16 is 4. That is a plane 4. It comes to the outside of the radical. Radical 3 is not a perfect square, and I can't break it down anymore. So my answer here would be 4 radical 3. Notice I am showing some work. You need to show something when you are simplifying your radicals. Some teachers last year taught it where you just put everything inside the radical, so you had something like this. That's fine. You're showing me those factors that you're using, right? So something, you don't necessarily have to have the lines on it like this. You could just write the two factors, write a multiply, and something like that. But something to the effect of that you're showing the factors you're breaking it into. And I highly recommend that you make sure you keep those radicals over those factors. Otherwise, you're going to make a mistake really easily. Okay, so that's just basic simplifying. Now, number two is what happens if I have a fraction in here that I have to simplify, right? Well, just like we looked at in our last one, when I am multiplying, if I'm doing insides times insides, the answers stay inside. I can think of the same thing here with my dividing, right? A fraction is really dividing. So a big square root with 5 over 3 inside is the exact same thing as the square root of 5 divided by the square root of 3, right? I can divide them both if they're on the inside, or I can split them apart and have them each in their separate one. Means the same thing. Now, if I had any reducing here, right? If I had a radical that was 15 over 3, right, then I would want to simplify that radical, and I would want to say, okay, well, I could divide both of these by 3 before I even think about the radical, and I would end up with radical 5, right? But here, I can't reduce anything with the 5 and the 3, so I just need to split it into the two separate radicals like I did in green there. Now, it looks like that's the only thing I can do. But if you remember to last year, the big thing with radicals is you can't leave a radical on the bottom of a fraction. We got to get it off the bottom of the fraction. If you recall, the way to do that is to multiply the bottom and the top by that radical. A radical times itself will clear the radical, right? If I think about what's going to happen here, what is the square root of 3 times the square root of 3? Inside times inside, this is going to give me the square root of 9, right? Well, what is the square root of 9? The square root of 9 is plain old 3. So notice when you multiply a radical times itself, the radical disappears and you just are left with the number inside. You don't have to show the square root of 9 step if you don't want to. Hopefully at this point you know multiplying a radical by itself clears the radical. Okay, so that's what we need to do if I have a radical in the denominator. I multiply the top and the bottom by that radical. On the top, I have the square root of 5 times the square root of 3. Both of those are inside, so I can multiply them together. 5 times 3 is 15. They were inside, so my answer stays inside. Radical 15 over radical 3. Now, if you notice, this is similar to that example I did right above it. However, notice on this one, the 15 is on the inside of the radical. The 3 is on the outside of the radical. So I cannot reduce that, right? They either have to be both inside or both outside to reduce. So in this case, that is all that I can do. Radical 15 over 3 is my answer. On my top example up there in dark blue, the 15 and the 3 were both on the inside. That's why I could simplify those some more. All right, number 3, now we are adding. So notice on these first two, I was multiplying, I was dividing. I don't have to have the same radical in order to multiply or divide. But when I am adding and subtracting, I have to have what we call like radicals. Like radicals means that I have the same number on the inside of the radical. So on this one I have 18, 32, and 75. None of those are the same, so I cannot add these. I can't add 18 and 32 just because they're both on the inside. It's very much like fractions, right? You cannot add fractions unless they have the same denominator. You can't add radicals unless they have the same number on the inside. So what do? Well, we go back to our things that we were doing in step 1 there, and we reduce or we simplify each one of these radicals to see if maybe there are some like radicals hidden inside there, but we just haven't seen them yet. So if I look at the square root of 18, what are the factors of 18 where one of them is a perfect square? That would be the square root of 9 and the square root of 2, right? With 9 being the perfect square. All right, how about the square root of 32? Let's see, factors of 32 would be 4 and 8, but 16 and 2 would be bigger, where 16 is our perfect square, right? Now my last one, 75, factors of 75 would be square root of 25 times the square root of 3, and 25 is my perfect square. So going back here, square root of 9 is 3, so I will have 3 radical 2 for my first one, plus square root of 16 is 4, so I'll have 4 radical 2 for my second one. Now this third one, you got to be careful, plus there was already a 2 outside here. I got to bring that down to the party, right? All I'm doing is simplifying the square root of 75, but the 2 is already there, so it's got to come down. Now the square root of 25 is 5. That number is also outside. Remember, all of these, when we have factors like this, that we're multiplying them together, right? 25 times 3. So if I pull something out to the front, anything that's already out there is multiplied times that radical, so I have to multiply those things. So 2 times 5 out in front, the radical 3 is staying there. Okay, so if I just simplify a little bit more, this looks like I have 3 radical 2 plus 4 radical 2 plus 10 radical 3, right? I'm multiplying those two together out front. Now I say, ooh, do I have any like radicals? I do. I have 3 radical 2 and I have 4 radical 2. Those are like radicals that I can combine. Now, just like if I had 3x plus 4x, I just combine the outsides, the coefficients. I get 7, but the radical does not change when I'm adding, right? 3x plus 4x is 7x. The x doesn't change. Same thing with adding radicals. 3 radical 2s plus 4 radical 2s is 7 radical 2s, right? The radical 2 doesn't change. And I just bring down the 10 radical 3 because it was not a like radical, so I can't combine it. So my final answer will be 7 radical 2 plus 10 radical 3. Okay. Little bit more here with multiplying. We gave you kind of some easy ones to start with because really essentially you're doing multiplying all along the way when you're simplifying. But sometimes you just have to multiply these radicals, right? So the key with multiplying and dividing, really, outside times outside stays outside. And inside times inside stays inside. Oh, there we go. So when I look at this, I see a 5 on the outside and I see a 6x on the outside. 5 times 6x would be 30x, and that stays on the outside, right? Then I have my radical, and on the inside, I have 2x times 6x to the fourth. 2x times 6x to the fourth. Well, 2 times 6 is 12. X times x to the fourth. This is really x to the first, right? 1x plus 4, or times 4 more x's. How many x's do I have? I'll have 5 x's, right? So I have x to the fifth. All right. That is how you multiply. But remember, we're never finished when I have radicals unless I've simplified the radicals. So I always have to double check before I say I'm done. In my last ones, I was doing the simplifying first, right? So I knew that they were simplified. Here, when I'm multiplying first, you really got to watch out for being able to simplify before you box in your answer. Remember, things on the outside, I can't do anything with. 30x is 30x. There's nothing I can do with it. What I'm looking for is the things that are inside the radical. The square root of 12x to the fifth. So this is really like 30x times square root of 12 times the square root of x to the fifth, right? Those are two different things. You can, you don't have to split it like this, but sometimes it helps people recognize that there is more to do. So the square root of 12 becomes the square root of 4 times the square root of 3, right? Square root of 4 is our perfect square. Now, x to the fifth is tricky, but it helps to maybe even look back up at the front. Remember, anything with an even exponent is a perfect square, right? What times itself gives you x to the fifth? Nothing. But if I think of this as square root of x to the fourth times the square root of x, right? What times itself gives me x to the fourth? X to the second, right? X to the second times x to the second would give me x to the fourth. So if I have x to the 10th, that's x to the fifth times x to the fifth equals x to the 10th, right? Hopefully this is coming back, although that part is one thing that people have a very hard time with in algebra and probably is something that they forget by the time they get here. All right, so if you do have a variable in there, you want to break it down so that you have the biggest even exponent possible. That's a perfect square. We could have simplified it way back here up at the beginning, right, and pulled an x squared out to the front way back there if we wanted to. That would be fine. But you can multiply first, you can simplify first, it doesn't matter, okay? But remember, to pull the biggest one out, you pull one variable off, just an x, and the rest would be even if you have an odd exponent to start with. All right, so what do we have here? I have 30x from the original multiplying. I'm going to bring out the square root of 4, which is 2, so I'm going to multiply that 2, right? I'm going to bring out the x squared from the square root of x to the fourth. Those were all our perfect squares. What do I have left on the inside? I have the square root of 3, and I have the square root of x, so 3x is staying on the inside. Last and final thing is just to multiply these things that are on the outside. 30x times 2x would be 60x to the third. Remember, there's that invisible one exponent there with the x's. 60x to the third, radical 3x. All right. Now we are getting into some trickier things. This number 5 is kind of like our transition from simplifying to solving. But here I have the square root of x squared minus 9. Now this one is tricky because I have a plus or a minus in here. This is a binomial, right? This is what throws everything off for people a lot of times. So we would be perfectly comfortable in saying I can simplify the square root of 9x squared, right? Or x squared times 9. Well, those are both perfect squares. So that would be 3x, right? Yeah, I could do that. I could do what is the square root of x squared over 9, right? So if I have multiplying inside, I'm good. If I have dividing inside, I can do that, right? The square root of x squared is x. The square root of 9 is 3, so I have x over 3. No big deal. But when I have plus or minus inside, that changes everything, right? So the first instinct is to say, okay, well that would just be x plus or x minus 3, right? But remember that the square root here means what times itself equals the inside. So if I think it's x minus 3, square root of x squared is x, square root of 9 is 3, bring down the minus sign, right? Well, x minus 3 times x minus 3, remember, this isn't just x squared, x times x and 3 times 3. This is FOIL. I have to remember that I would have to distribute here, right? I'd get x squared minus 3x, oops, minus 3x plus 9, which would be x squared minus 6x plus 9. That's not it, right? Look at this. That's got this guy right here. That's out. Okay, well, some people think, okay, so it's not x minus 3, but it should be x plus 3. Well, remember, x plus 3 times itself, supposed to give me x squared minus 9. Oh, same idea here, right? If I distribute these, x squared plus 3x plus 9, ooh, that would give me x squared plus 6x plus 9. It didn't get rid of it, right? So that one doesn't work either. I'm not there. So the thing is, when you have a plus or a minus inside this radical, you cannot simplify it. We just write cannot be simplified, or you just rewrite your answer exactly the same and don't do anything, right? Square root of x squared minus 9. I didn't do anything because I have that plus or minus inside. So remember, all of these things for simplifying works if you're multiplying inside or if you're dividing inside. That's when you can simplify. If you have adding or subtracting inside, you're done. That's it, okay? All right, so now let's move into our solving. Do you remember how to solve these quadratic equations? Now, if you look at number 6, I have 49x squared plus 9 equals 25. I notice that I have an x squared in here, but that's it. I have no plain x. So if I'm in my radical mind here, that I have been in the last few problems, I'm going to say, well, I can get that x squared all by itself and then take a square root, right? And the big key is that I have only x squared, no x term, right? That's why this works in this one. So if that's the case, I get my x squared alone. So I have to move the loose guy first. I've got 49x squared equals 16. Now this is the other thing, right? The x squared has to be completely by itself, so I have to divide by 49 first. Now a lot of you are like, but 49 is a perfect square, I could just take the square root. I want to show you a method that will work even when you don't have perfect squares, because remember back up here, number 1, our whole point was what to do when you don't have a perfect square, right? So this method where you get the x squared completely alone before you take that square root, that method will work even if you don't have perfect squares. So really maybe make a note here, get x squared alone before square root, okay? All right, so if I divide both sides, ooh, now 16 divided by 49, I can't, that doesn't divide, right? That's okay, fractions are fine, remember? We did fractions. Back up here, we know what to do when I have a fraction, no big deal. Especially these fractions, right? So do not ever give me a decimal. Never, ever, 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 ever. No decimals ever. Decimals and radicals, yuck, okay? Leave it as a fraction, because watch what's going to happen right now. I'm going to take the square root to get x by itself. I'm going to take the square root of the right-hand side as well. Now you can think of it as one big square root, or you can think of it as little square root on the top and little one on the bottom. It all means the same thing, right? So if I think about, okay, this cancels out, x squared and x, they're inverses. The square root of 16 is 4. The square root of 49 is 7. I get a fraction, right? 4 over 7. But you need to be careful. Because remember here, which we didn't talk about when we just have radicals, but now that we're into solving, the radical wasn't given to us in the problem. So this means what times itself equals 16? Well, that would be 4 times 4 equals 16, right? But negative 4 times negative 4 also gives you positive 16. So you need to have two answers here. I could have positive 4 over 7, or I could have negative 4 over 7. We need to have two answers. When you write the square root sign in order to solve an equation, if the square root is not given to you in the problem, that's when you need to have two answers. Now we could write this as plus or minus 4 over 7. Or you can write them separately, 4 over 7, negative 4 over 7. I will tell you for today's homework, when you're doing it in ClassKick, there's no way to type in the plus or minus symbol. So you would have to type them as two separate answers, 4 over 7, comma, negative 4 over 7. But both of those mean the same thing. And when you're doing your work on paper, you can write it either way that you want to. Remember, so that's when you write the square root sign, it's not given in the problem. Got to have plus or minus on the next step. All right, let's take a look at number 7. 3 radical 5 squared plus 3 radical 2 squared equals x squared. So again, x squared, no x term. So we can really think, hey, I can use a square root in this problem. Now you're probably thinking, hey, let's square root right away. But remember, when you're taking your square root, you're taking a square root of the entire left side and the entire right side. And remember what we talked about just a minute ago. Can I take the square root when I have a plus or a minus? No. So that's why you cannot just take the square root right away. I have to get it down to just one number before I can take the square root. So instead, I'm going to have to actually square these things. So I have 3 radical 5 squared. No plus or minus in there, which means I need to square the 3. 3 squared gives me 9. And I need to square the square root of 5. Both things, right? What is the square root of 5 squared? Well, square root, squared, cancel each other out. I get 5. Now I'm going to multiply those, right? Because this was really 3 times radical 5. So when I square the 3, I get 9. I square the square root of 5, I get 5. I'm going to do 9 times 5, right? All right, same thing over here for the next one. I'm going to square the 3. I get 9. I'm going to square the square root of 2, which just gives me 2. So I'll have 9 times 2 there for that one. All right, 9 times 5 is 45, plus 18 equals x squared. I can still combine these guys, right? Like terms here, 45 plus 18 gives me 63. All right, now I have just one single number and an x squared on the other side. So now I can take the square root. Okay, now notice, I am making that square root myself, right? So my next step has to have a plus or a minus. I'm going to have two answers here because I created that square root in order to solve it. But the square root of 63 is not a perfect square. I'll move this down. Oh, so is it no solution? No, we go back to what we did in that first problem where we just simplify our radical, right? So let's see, 63. Well, that would be the square root of 9 times the square root of 7. 9s are a perfect square, right? So I'm going to, square root of 9 would be 3. Square root of 7, I can't simplify. But don't forget, I need a positive 3 radical 7, and I need a negative 3 radical 7. So I need to have two answers here. Negative 3 radical 7. Because I wrote the square root sign, right? Or you could write that as x equals plus or minus 3 radical 7. Again, you won't be able to do that in Classic, but you can do that if you're writing it on your paper, plus or minus, and the answer, because we wrote the square root sign. Hopefully this is coming back to you. This is all review, but I know it's been a while. All right, number 8, x squared equals 12x. Oh boy, now on this one I have an x squared and an x, right? Can I take the square root of x? No, I have no idea what that means, right? No, no, no. Okay, now many people then want to say, okay, well, I'll just divide both sides by x. Yikes! You cannot ever divide by a variable, okay, because then you get rid of answers. When I divide by x, I have lost an answer completely. If I just divided by x, I'd get x equals 12, and that's it. But when you do this properly, you should get 2 answers, right? Hopefully that's ringing a bell from last year. So on this one, when I have x squared and an x term, that means I need to factor. And when I factor, I have to get it equal to 0, right? My equation has to equal 0, has to be in standard form, and then I can factor it. So my first step in this one is not to square root, it's not to divide, it's to subtract 12x from both sides. I want to get it to equal 0. So I have x squared minus 12x equals 0. And I want you to write a note. Never square root x or divide by x, ever, okay? All right, so I've got it equal to 0. Ooh, how do I factor something with only 2 terms? Let's see, what are my methods to factor again? I have factor box, which I'm sure all of you are remembering. Factor box is 3 terms. Okay, I have GCF. GCF is any number of terms. And I have dots, right? Difference of 2 squares. This is 2 terms. Difference of 2 squares means I have to have subtraction, and both have to be perfect squares. If I look at my 2 terms here, ooh, 12 and x are not perfect terms, so this is not dots. What I need to do here is GCF. What do these 2 terms have in common? They both have an x. So this is going to be x is my GCF. What do I have? X times what gives me x squared? X times x. X times what gives me negative 12x? Negative 12. All right, so when I factor by GCF, I take that GCF out in front, put parentheses. Whatever I would have to multiply by to get that original polynomial is what goes in the parentheses. Now that I have my factors, the process is to set each factor equal to 0 and then solve your mini equation. So here's one factor. So I have x equals 0. Here's my other factor. I have x minus 12 equals 0. Now the x minus 12 needs a teeny bit of super simple work. Okay, I get x equals 12. So I have 2 answers on this problem. My 2 answers are x equals 0 and x equals 12. You could just write it like that, or you could say x equals 0, comma 12. When you are doing it in Classic, again, you're going to have to write it like that. But if you're doing it on paper, you can just box in both answers. You must show this step where you make your mini equations, okay? Yes, I know that it is very simple math. I'm sure you can do it in your head. However, so often when you don't show that step, you goof up a negative and you say my answer is negative 12, and it's not. So you have to show that step. Remember back when we wanted to divide by x in our first step, we only got the answer of 12. When you solve it correctly, you should have those 2 answers, 0 and 12. Remember, when I have that quadratic equation, the x squared, most of the time you're going to have 2 answers. Here's my 2 on this one. If you look back on the last ones, it was the plus and the minus. Those are my 2 answers, right? So that's your indication. All right, if I'm looking at number 9, x squared minus 13x plus 40 equals 0. So if I look here, I've got an x squared and an x, so I cannot do a square root. I need to factor. Ooh, nice thing about this one is that it equals 0. So I don't have to move anything. I'm all ready. Everything's lined up in the right order. I can just think about what method do I want to factor. Okay, so I could do a GCF, but it doesn't look like anything here has a GCF. There's no x in the 40. 13 isn't even, I mean, I don't think we have a GCF here, but you could look for that. It's not dots because it's not two terms, which means this is a factor box. All right, so my factor box here, if you remember how to do this, now I say factor box, but if you can factor this without the factor box, if you can go straight to what two binomials multiply together to give x squared minus 13x plus 40, good for you. You do not have to show this factor box. This is for those of us who are having a hard time remembering how to factor, right? So for a factor box, your first term goes above the first column. Your last term goes above the second column. Your middle term slides down into the nook. I need to figure out what things multiply together to give x squared and 40 that will add up to negative 13x. That's the idea here, right? So then I say, okay, everything on the inside is going to be multiplied. So what times what gives me x squared? Oh, that would be x times x, right? And I think, okay, what multiplied together would give me 40? 4 and 10, it's not going to make the 13. How about 8 and 5? Oh, okay, so now when I multiply, I'm multiplying on the inside to get to the outside. So if I'm multiplying across here, x times 8 is 8x. Multiplying across here, x times 5 is 5x. Ooh, that would give me positive 13. I need to get negative 13. Negative 8 times negative 5 would give me negative 8x plus negative 5x on the outside. Yes, 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 yes. Now it still works because negative 8 times negative 5 still gives me positive 40. So watch your negatives in there. Sorry about the bell. So everything on the inside of a factor box gets multiplied, multiply up, multiply across. Everything on the outside is added together. So that's why I'm doing negative 8x plus negative 5x to give me negative 13x. All right, then the last tricky part about our factor box is to remember that the diagonals are our parentheses. So x minus 5 is one set of parentheses, and x minus 8 is the other. Please make sure when you're transferring from factor box into parentheses, the first column is the first term in your parentheses, the second column is the second term in your parentheses. It's not negative 8 plus x, it's x minus 8. Also remember, if you need those negatives to get a negative answer, the negatives in your factor box always come in the second column. We wouldn't do negative x plus 8, that's confusing and kind of crazy. So always put those negatives in that second column if you need it. This is all stuff we learned last year, so hopefully it's coming back to you. Now I'm at that place like in my last one where I have my factors, right? Make sure you bring down that equals 0 because I'm not finished right now. I need to take each factor and I need to make my mini equation. So my first factor is x minus 5, so my first equation is x minus 5 equals 0. My second factor is x minus 8, so I have x minus 8 equals 0. Yes, you have to show this step where you make your mini equations, okay? So let's see, but now super easy. If I add 5 on both of these, I get x equals 5. If I add 8 on both of these, I get x equals 8. Or you could write them all as one, right? So you get an answer of 5 comma 8 or 8 comma 5. It doesn't matter the order that you write them in, right? And remember that the big reason you got to make sure you write that step with the parentheses and then make your mini equations is because it's so easy to say my answers are negative 8 and negative 5, and they are not. So make sure you write that step. All right, we reviewed GCF, we reviewed factor box. So what if I get an equation that looks like this? I apologize, that is the same problem. This was supposed to say minus 29. I'll fix that before you probably see it. Okay. So instead of having the same problem, I wanted one that was very similar. However, this says x squared minus 13x minus 29 equals 0. The last one was x squared minus 13x plus 40. So the reason there that I could do my factor box is because multiples of, or my factors of 40, I could figure out a factor box. But if I think of square root of 29, or excuse me, the factors of negative 29, that's just 29 and 1. There's no way that that is going to add up to 13. It's just not going to happen, right? So if you have something like this where it looks like I should be factoring this, but there's no way that the factoring is going to work out, that's when we have to use our quadratic formula, okay? Now this should be a very last resort. I even hesitate to have you remember it, but the thing that we want to remember is quadratic formula does work on every equation, but it's so much work and there's so many chances to make a little mistake that you should be factoring 99% of the time. This is only your drastic measures when factoring absolutely doesn't work. So if you remember your quadratic formula, x equals negative b plus or minus square root b squared minus 4ac divided by 2a. Or some other song that maybe you heard from your teacher if your teacher showed you a different song last year, but most of you will remember that, right? So I say, okay, well, a, b, and c, where are these coming from? So remember, this is coming from standard form. Standard form is ax squared plus bx plus c equals 0. So I find my equation is in standard form when it equals 0. Then a is the coefficient of x squared. So a in this case is 1. b is the coefficient of x. And c is our constant, right? Our plain number, so negative 29 in this case. I do really, really, really want you to make sure you write down A, B, and C if you have to use the quadratic formula, but again, this is last resort. Almost never will you be doing this in class, but just in case, I wanted to remind you. So if I have my quadratic formula here, I have negative B. And b was negative 13. Notice I'm using parentheses when I'm plugging in my actual numbers, right? Especially when you have negatives. And here I have b squared, so I have negative 13 squared minus 4 times a times c. A was 1, c was negative 29, all divided by 2 times a, which was 1. Okay, now the reason you got to use parentheses is because it's so easy to make a negative mistake here, right? It's really easy to miss some of those things when you don't use parentheses, and it's still easy to miss even when you do, and that's why I always want you to try to factor as your first step. But if I look on this, I see negative 13. That's going to turn to positive 13 out front. Plus or minus square root. Now this is why I need parentheses. Negative 13 squared is positive 169, not negative 169, okay? And now my next one, negative 4 times 1 times negative 29. Two negatives here mean that I have a positive answer. 4 times 29 gives me 116 if I use my calculator. Over 2 times 1 is just 2 down at the bottom. Okay, now I would do 169 plus 116, so I get 13 plus or minus radical 285 all over 2. Now I would really try to simplify the square root of 285 if possible, right? That's what I would do there, but in this case, there are no perfect square factors. I'll give you the hint before we spend a ton of time trying to do that. So you can't reduce it. You would have to read directions carefully. Sometimes they want you to leave answers around your answers, but only do that if the directions tell you to. If they said round to the nearest hundredth, you'd get your calculator out at this point. You'd type in 13 plus square root of 285, hit equals. Then hit divided by 2. Make sure you do the top first, hit equals, and then divide by the bottom, or your calculator will mess it up. But only round if your directions tell you to do that. Otherwise, you would leave your answer just like this. All right. We have reviewed a ton. Hopefully you can use this to just come back and watch the sections you need if necessary. But we have reviewed all there is to do with radicals and solving quadratics, so hopefully you're back on track.